Last video I showed you Goldbach's conjecture. Every even number greater than 2 is the sum of true primes. Simple enough, nobody's proven it, but nobody's disproven it either. It just is sitting there. And I ended that video saying we do not know if it's true or not. But here is a question I did not ask. What if we can never know it? Not that it's really hard to figure out, mathematically, provably impossible to ever prove. Axioms are a set of propositions that we assume to be true. Now the idea from this was, if you have a solid enough set of axioms, you should be able to prove or disprove anything from them. Mathematics would be complete in that sense. However, in 1931, a 25-year-old named Kurt Gödel destroyed it. Gödel's incompleteness theorem says this: any set of axioms that is powerful enough to do basic arithmetic cannot be both complete and consistent at the same time. Consistency means your axioms do not contradict each other. You cannot prove something is both true and false. That's the minimum requirement for math to make sense, right? Now, completeness means every true statement can be proven from your axioms. But Gödel says that you cannot have both. You have to pick one. Now, this implies that there can exist true statements in mathematics that you can never prove. One cannot disprove them either, but to prove it, we have to add more axioms. But then these axioms will give rise to another new set of statements that you cannot prove. If your system is consistent, and we need it to be, then there will always exist true statements that cannot be proven within that system, no matter how many axioms you add. But how do we know this to be true? Gödel proved this by constructing a statement that essentially says this: this statement cannot be proven. If the statement is false, then it can be proven, but that means you proved a false statement, which breaks consistency. So it must be true then. But if it's true, it just told you that it cannot be proven. So it becomes a true statement with no proof, much like Goldbach's conjecture. But does this actually matter? For most of everyday maths, not really. Calculus is just fine. But for the big foundational questions, the ones like Goldbach that nobody can crack, Gödel's theorem means we have to accept something really uncomfortable. Some of these problems might not be solved merely because we're not smart enough. They might be unsolved because no proof even exists. And we cannot even tell which one those are. Not always. And I find that really beautiful, because mathematics, from the first glance, is this incredibly precise logical structure. But right at its foundation, there are holes that can never be filled.